Hello guys, welcome back to my YouTube channel. My name is Kislay Kumar. I am currently studying in Sri Venkateswara College of Engineering, Bengaluru. My USN is 1VE23CS080. I am currently in semester 3rd and my section name is Bhaskara. Today's subject is we're gonna learn about the subject operating system. Subject code is BCS303. Today's topic is virtual machines and operating system debugging. Let's get started with our topic. Virtual machines and operating system debugging. Welcome to this presentation on virtual machines and operating system debugging. We'll explore the concept behind virtual machines and delve into the essential techniques for effectively troubleshooting and debugging operating systems within these virtual environments. Get ready to navigate the virtual world and uncover the secrets of operating system debugging. First, we gonna learn about what is virtual machines. Introduction to virtual machines. A virtual machine VM is a software-based emulation of a physical computer system. It allows you to run multiple operating systems simultaneously on a single physical host machine, creating isolated and independent environments. Think of it as virtual computer within your computer. It's a powerful tool for development, testing, and deployment, enabling you to isolate applications and reduce the risk of conflicts. Virtual machines are widely used for various purposes, including software development, testing, server consideration, and disaster recovery. They offer flexibility, efficiency, and cost effectiveness, allowing you to create and manage multiple virtual environments without the need for dedicated physical hardware. Benefits of using virtual machines. There are four, four basic benefits of using virtual machines, which are isolation and security. Virtual machines provide a secure and isolated environment, preventing applications running within one virtual machine from affecting others. Resource optimization. Virtual machine enable efficient use of physical hardware and by sharing resource among multiple virtual environments. Flexibility and scalability. Virtual machines offer flexibility, allowing you to easily create, modify, and scale virtual environment as needed. Cost effectiveness. By consolidating multiple virtual machines onto a single physical server, you can reduce hardware costs and simplify management. Types of virtualization technologies. There are again four types of virtualization technologies, which are system virtualization, process virtualization, network virtualization, and storage virtualization. System virtualization is the virtualization which emulates an entire physical computer system, allowing multiple operating systems to run concurrently on a single host machine. Process virtualization is a virtualization which virtualizes individual processes, enabling them to run in isolated container, providing resource management and security benefits. Network virtualization is a virtualization which virtualizes network components like switches and routers, providing flexibility and efficiency in network management. And the last, storage virtualization is a virtualization which pools storage resources from multiple physical devices to create a single centralized storage system. Virtual machine architecture. Virtual machine is is, is consist of four types of architecture, which are processor, memory, storage, and networking. So you can say that it is made up of these four things. Virtual machine is made up of these four things, which are processor, memory, storage, and networking. Processor. Processor is the virtual CPU manages and executes guest operating system instructions. Memory. The virtual memory manages the allocation of RAM to guest operating systems. Storage. The virtual storage system simulates hard disks, drives, providing storage space for the guest operating system. Networking. The virtual network interface card allows guest operating system to connect to the network. Operating system debugging concepts. So there are five concepts for which in for operating system debugging, which are understanding the OS architecture is crucial for effective debugging. Knowledge of key components like the kernel, drivers, and user space is essential. Identifying and isolating the root cause of the issue is a primary goal of OS debugging. This requires a systematic approach and careful analysis of system behavior. Analyzing logs, crash dumps, and system traces provides valuable insights into the operating system's state and behavior. These artifacts can help pinpoint the source of the problem. Utilizing debugging tools such as debuggers, memory analyzers, and performance profilers enhances the efficiency and effectiveness of the debugging process. Troubleshooting common OS performances issues such as slow startup, unresponsive applications, or memory leaks involves a combination of debugging techniques and optimization strategies. Common OS debugging techniques. So there are again four most common OS debugging techniques, which are breakpoint tracing, memory dump analysis, and system log analysis. So let us learn a simple. So let us know what they are. Definitions. Breakpoint. Pause execution of a program at specific points to inspect variables and memory contents. Tracing. Record a detailed log of function calls and system events to identify the sequence of actions leading to the issue. Memory dump analysis. Inspect the contents of memory at a specific point in time to detect memory leaks or corruption. System log analysis. Examine system logs for error messages, warnings, or unusual events that might indicate the source of the issue. Analyzing OS logs and crash dumps. So there are basically five types of OS logs and crash dumps, which are log file types, kernel logs, system logs, application logs, and crash dumps. Log file types, I guess everyone knows, so let's start with kernel logs. Kernel logs provides insights into the kernel's internal working and potential issues. System logs records events and errors related to system services and applications. Application logs capture events and errors specific to individual applications. Crash dumps contain a snapshot of the system's memory of this time offline and execute a valuable debugging infrastructure. Utilizing OS debugging tools. So there are four types of debugging tools, which are debuggers, memory analyzers, performance profilers, and system monitors. Debuggers allow step-by-step execution of code, inspection of variables and memory contents. Memory analyzer help detect memory leaks, fragmentation, and other memory-related issues. Performance profilers measures and analyze programs' performance to identify bottlenecks and optimize resource utilization. System monitors provide real-time insights into system performance, including CPU usage, memory consumption, and Disk in and out activity. Troubleshooting OS performance issues. So there are four types of issues which are common in OS systems, which are deter, uh, identify the issues, gather data, analyze the data, and implement solutions. Determine the specific performance problem, whether it's a slow startup, unresponsive application, or high CPU utilization. Gather data, utilize system monitoring tools to collect data on CPU, memory, disk, and network performance. Analyze data. Examine the collected data to identify potential bottlenecks, resource protection, and or inefficient process. Implement solution. Apply appropriate solution including configuration adjustment, resource optimization, or code modifications. Thank you guys for watching my video. Hope you guys like my video. So hit the like and the subscribe button. And if you guys have any queries regarding this video, so please ask Google. Don't ask me. Thank you.